These are the first two questions on the review where you have to graph exponential equations, and then you have to identify the domain and the range and what type of function it is. Remember that the kind of function you have to write exponential growth or exponential decay. If you just write exponential, it's not a complete answer and will have to be counted wrong. In our graphs, remember that we usually like to do -2, -1, 0, 1, and 2 for our x values. Those are pretty standard for, just plugging in values on a table. So these are my x's, and I'm going to find my y's. So the first one, if I'm going to plug in -2, would be 2 to the -2 exponent. Remember that a negative just means you would flip it, make it, the reciprocal of 1 over 2 squared. And so that's 1/4 for that y value there. For -1, 2 to the -1 means it's 1/2. 2 to the 0, anything to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. So now I'll just plot. -2 is at a quarter. So -2 is at a quarter. -1 is at a half. 0 is at 1. 1 is at 2. And 2 is at 4. And it's just going like this. For our graph, put arrows on it. This would be exponential growth. Because as you go to the right, it's going up. The domain on this is all real numbers, because to the left it would keep going, to the right it keeps going. The range is y greater than or equal to 0, or not equal to, just greater than 0, sorry. Fix that. Y has to be greater than 0, because we actually have an asymptote down here. This line will approach 0, but it will never actually be equal to 0. On the second one, I'm going to do the same thing, values of x and y. I'm going to use, again, -2, -1, 0, 1, and 2. And this being 1/3, you can tell just by looking at that, when you have a value that's less than 1 here, to the power of x, that will be exponential decay. So plugging this in, 1/3 to the power of -2 means that you really have 3 squared, which is 9. 1/3 to the -1 is 3. 1/3 to the 0 power is 1. 1/3 to the power of 1 is 1/3. 1/3 squared is 1/9. So here -2 is at 9, which is off the chart. -1 is at 3. 0 is at 1. 1 is at 1/3. 2 is at 1/9. It's just going to keep getting smaller, but it's never going to be 0. So that. And this is exponential decay. It's going down as you go to the right. The domain, again, is all real numbers, and the range is, again, y greater than 0 for that problem.